बच्चों, तो हमने लास्ट वीडियो में एक बहुत ही शानदार सा क्वेश्चन दिया था जिसका पार्ट सी आप लोगों के लिए छोड़ा था सॉल्व करने के लिए। तो आई एम श्योर मोस्ट ऑफ यू मस्ट हैव ट्राइड, और ये सबसे टफेस्ट पार्ट है इस क्वेश्चन को, जिसमें बहुत सारे महारथी जो है वो हिल जाते हैं। अब देखो इस क्वेश्चन को जो है वो मैं कैसे बहुत ही बेहतरीन तरीके से आपके सामने दूंगा, और आपको बताऊंगा जो कैसे जे एडवांस इस आइडिया पे क्वेश्चंस को डिजाइन कर सकता है। ठीक है, तो आई नॉट यूज एनी फेंसीफुल आइडियाज और फेंसीफुल नोटेशन, बहुत ही सिंपल तरीके से रॉ फॉर्मेट में आई एम गोइंग टू गिव यू द एक्सप्लेनेशन। तो आप ध्यान से सुनिए। आई हैव ऑलरेडी डिस्कस्ड ऑप्शन ए जो है वो सही होगा, एंड ऑप्शन बी जो है वो भी सही है, बिकॉज ऑप्शन डी इज क्लियरली करेक्ट। सो फॉर दोज हु हैव नॉट सीन द लेक्चर बिफोर, दिस वाज द गिवन प्रॉब्लम। आप पिछले लेक्चर्स मैट्रिक्स के प्लेलिस्ट में जाके देख सकते हो, और पिछले वीडियोस में। S is the set of matrix such that A, B, C belongs to integer world. G is its inverse. So G is set of all matrix A which is belonging to set S such that A inverse also belongs to set S. मतलब they must have same DNA, same genetics, same family से belong करता हो। तो फर्स्ट ऑप्शन था जो that of M is plus minus 1 for every member M belongs to G, and whose explanation is very simple, क्योंकि if we have any matrix M belonging to set S and M inverse also belongs to set S, so since we know M inverse is equal to Y, so that of M into that of 1 by M is 1, because that of M inverse is 1 by that of M. अब चूंकि सेट एस का कोई भी मैट्रिक्स इफ आई टेक, ऑफ कोर्स उसका डिटर्मिनेंट एक इंटीजर होने वाला है, बिकॉज इट्स प्रोडक्ट ऑफ इंटीजर्स। सो इफ दिस गाय बिलोंग्स टू इंटीजर वर्ल्ड, so similarly 1 by det of m must belongs to integer world, so product of two integer will be 1 if and only if both is either 1 or minus 1. Let's say if mod m is 5, that of a matrix m is 5 from set S, तो फिर a inverse उस सेम जेनेटिक्स का नहीं हो सकता, क्योंकि उसका डेट 1/5 हो जाएगा, जो कि पॉसिबल नहीं है, बिकॉज ए बी सी आर इंटीजर्स। ठीक है, और सिमिलरली हमने ऑप्शन डी आप डायरेक्ट चेक कर सकते हो जेई फैशन में, इसका इन्वर्स निकालो और वो एग्जैक्टली उसी फॉर्म में होगा, ए बी सी के फॉर्म में, और इवन नंबर्स यहाँ पे दिखेंगे 6 और 8 जब आपका इन्वर्स लोगे तो। जो सबसे टेक्निकल पार्ट था इस प्रॉब्लम का, एंड विच इज टफ डेफिनेटली, इज एम हैज फाइनाइट एलिमेंट। तो ये जो है वो गलत ऑप्शन है, क्योंकि मेरे पास m के पास जो नंबर ऑफ एलिमेंट्स होंगे वो होंगे इनफाइनाइटली मेनी। बट नाउ द बिग क्वेश्चन इज हाउ टू डू इट, एंड ऑल्सो कैन वी रूल आउट ऑल द इनफाइनाइटली मेनी सॉल्यूशंस ओवर है, क्या मैं उसका एग्जॉस्टिव सेट बना सकता हूँ? तो इसको बहुत ही शानदार तरीके से करते हैं, आप तो ध्यान से देखना। सबसे पहले एस में कोई भी एलिमेंट होगा तो उसका डिटर्मिनेंट अपन के पास क्या होने वाला है? 1 होने वाला है। तो अगर मैं that of m निकालूं, so if I call this matrix to be m, डिटर्मिनेंट ऑफ m अगर आप फाइंड करते हो तो वो काफ़ी एक इंटरेस्टिंग वैल्यू है। ए बी सी में एक रिलेशन आएगा, एंड दैट रिलेशन विल बी ए क्यूब प्लस 2b³ प्लस 4c³ माइनस 6ac ए बी सी। सो बेसिकली ये वाला जो क्वांटिटी है डेट, ये मेरे पास +1 और -1 दोनों हो सकता है, राइट? अगर मान लो मुझे अगर इसको सॉल्व करना है, सपोज इफ आई एम टेकिंग +1 वाला केसेस, so now basically I have to find all integers a b c belongs to integer world such that ये एक्सप्रेशन वैलिड हो। तो क्लियरली आई हैव टू फाइंड अ मैट्रिक्स m जिसका det 1 हो। तो आप अगर ये ऑप्शन एक मैट्रिक्स वी हैव ऑलरेडी फाउंड, क्यों? क्योंकि अगर मैं एक ए बी सी का एक वैल्यू लूंगा, सपोज ए को 1 ले लिया, बी को 1 और सी को 1, सो इज 7 - 6 दैट वर्क्स। इट मीन्स मेरे पास जो करस्पॉन्डिंग मैट्रिक्स आया, that I can tell is 1 1 1 2 2 1 2 and 1. Clearly that is 1. So one of the solution will be this, that I can tell it maps to 1 1 1 as the integral solution. Now something crazy and magical point is happening. What if I take, let's say if this matrix is M, now I'm claiming if any power of M, if I tell, so that's a claim in which I'll prove just now. Let's say let's try first M square. So if I'll square this matrix, I'll get 1 to 2 1 1 2 1 1 1. Let's do first experimentation, and then we'll try to feel why it works. So that gives 5 6 8, and we have first into second is 4 5 6 and 3 4 5. And that's crazy because this is exactly in the fashion of A, 2C, 2B. You can see 2C should be present, BB sum should be over here. So 2C is present, 5 and 3 sum is over here. So it's exactly in the same structure. So this also belongs to set S. Okay. Now, what does it mean? So if I'll try to decode what's the value of A, B, C, so A is going to be 5 here, B is 4, and C is 3, because this quantity is A, is 2C, and that's 2B. And clearly, indeed, if I'll try to check, let's check whether 5, 4, 3 is the solution of this equation. So 5 cube plus we have 2 times B cube, 2 times 4 cube plus 4C cube, 4 into 3 cube minus 6 ABC, 6 into 5 into 4 into 3 is this literally 1. It's 125 plus 128 plus 108 minus that gives 300. And that is surprisingly 1. Oh my god, what's happening? That's really enchanting. Because what I have done is, if I have found a solution, 1 from here, I am able to build infinitely many solutions over here. So m square works. What about m cube? And it's no wonder, now you might be doubtful, because if I'll take m cube, so let's say 5, 6, 8, 4, 5, 6, 3, 4, 5. So first feel wow and then how, right? 112, it's 111. और अगर मैं इसको मल्टीप्लाई करूं तो मेरे पास आ गया 19, 24, 30. यहाँ क्या आएगा 4 plus 5, 9, 15. That gives 19. This is 8, 10, 24, 12, 15. That guy is 19. And again I can still 12 plus. So we have 24, 30 over here. 24 is matching. And you can see A plus C, so B plus B should be 2B. So 15 plus 15 should appear here, 12, 19, 13. So that gives a solution. A equals 19, B equals 15. Remember, B place is over here, C is over here, and C that gives 12. Okay, let's try 19 cube plus those stuff. So if I check it, I'm getting 19 cube plus 2 times of 15 cube plus 4 times 12 cube minus 6 into 19 into 15 into 12. That gives 6850 plus 6750 plus 6912 minus 20520. Oh my god, oh my god, that is insane. So we got a still one. So now my claim is I can find infinitely many solutions. If m to the power 26, you'll get some answer, some cat, doggies bhai, buffalo, and then you can find a equals cat, whatever appears over here, and b equals doggies by 2, in fact buffalo by 2, and c will be doggies by 2, right? And so on. So we have found already infinitely many solutions for all n belongs to it. Now this was just what you call a guess solution, and it worked. It feels like already I know the solution, and then I'm forcing to prove it. Okay, but the power of matrix is quite revealed there in a crazy way. Now the big question is why it works. Okay, and that is super interesting. So first I have to show, like, if any m is the member of society S, set S, then m to the power 2 will also be from set S. M cube will also be same set S. In fact, m ka power n will belongs to set S for every natural number belonging to n belongs to every natural number. Now that is something interesting. One way of proving is you take two matrices of that format, A2, C2, B, blah blah blah, and then A1, 2, C1, 2, B1, multiply them and try to show that exactly mimics the format of what you have done, right? So let's say if I'm giving you a time to do together with me, let's say one crude logic will be, if I give this matrix BA2C CBA, multiply with, let's say, 1 2 C1 2 B1 matrix of similar family, b1 a1 to c1 c1 b1 a1. And then can you tell like whether this answer will exactly be of the same DNA? Same DNA means this should match. Again, this guy should match. This summation should be exactly over here, right? And like the diagonal elements should match. It should be A, and we have exactly B and C over here. So B ka half and 2C ka half. Okay, so if I multiply these two matrices, will I exactly get the same? So let's try to think and multiply. So let's see if I multiply the first one. So we'll get A1 plus 4C1 plus that stuff is 4B1, right? And plus blah blah. So we'll have more terms over here. Similarly, in the diagonal, we'll have next term is 2C1B1. So if I'm talking about the first diagonal term, and second diagonal term will get in diagonal. So I'm focusing on these diagonal terms first. So what we'll get? We'll get 2BC1 plus AA1 plus 2B1C. So is it exactly same as like, so are they exactly same? So let's try. Clearly it's not, because you can see the first stuff, it should be actually the first stuff will be a1 and then 2cb1 and we have 2bc1, right? And that exactly matches with this. Oh, so I can tell if I take any two member from the set S, their product is also from set S itself. And since that of this guy is 1, that of this is 1, so that of this must be 1. So you don't need any fanciful idea to tell uh, and argue if M belongs to set S, their next generation has to be from set S. But now someone, especially for teachers who is seeing this lecture, it's something called, like group theory. So the fundamental idea of group theory is exactly what I have discussed right now. So I'll make something very interesting and magical. And let me ask just this simple question. If, of course, in connection with the same question, if I have a cube plus 2b cube plus 4c cube minus 6abc equal to 1, and I want to find the number of integral solution ABC in integral world, how will you do about this? So here we go with the solution. I'll create a magic matrix because now you know the context, and that will be A 2C 2B, BA 2C, and CBA, and this matrix value exactly has to be 1. So now I'm trying to find all matrix in this fashion where A, B, C are integer, so that this determinant gives me 1 as the answer, right? And with some trial, of course I got what you call a seed solution, and that from that seed we germinated the entire forest of solutions. At least that's one way of generating infinitely many solutions. But here is some creative way. So the matrix S is not just a random collection of number. It's a translation of some specific type of number, and that's something literally uh, beautifully dangerous. So what I'm telling you, consider now a set of number. Listen very. So let me switch to a new world actually, where I'm defining a number alpha as a real number with a plus b third root 2 plus c times third root of 4. Now you must be wondering where from the sky I have defined this. Okay, so all of a sudden, how someone will think of defining this? Now remember, what I'll do is I'll decode this number with respect to this matrix row and column. For example, ABC, I'm decoding the first column of matrix by a number alpha, which goes like alpha plus b third root 2 and c times fourth root 4. Uh, and of course, you must be wondering like why I've chosen this some special combination of these numbers, and that will be clear very soon. So let's call that to be omega. Let's call 2 ka power 1 by 3 is omega. That gives omega square equals 4 ka power 1 by 3. So I've defined a number a plus b omega plus c omega square, where omega is not cube root of unity. It's basically 2 ka power 1 third. It's just purely real number. Okay, now you see the crazy game. What is alpha omega? Okay, let me ask the question. So that's b omega square plus c omega cube. And by definition, what's omega cube? It's 2. Okay, so it's a omega plus b omega square plus 2c, and you are like, oh, what's great about it? Yes, there is some greatness, because if I denote this number abc with an ordered triplet, let's say that's my coding abc. So whenever I see golu plus something bholu times third root of 2 plus golu ka bhai times 4 root third root 4, I'm decoding it to be abc, an ordered triplet. So this structure is exactly equivalent to this structure, and that in turn is equivalent to the column structure we are putting over here. And this is known as isomorphism. Iso means equal and morphic means same type of morphology. Okay, same genetics in that sense, you can tell. So far so good. So in that sense, how will I decode alpha omega? So you see, I'll decode this as a comma b comma 2c. Okay, so that's cool. So basically I'll not decode this as a comma b comma 2c. Rather, I'm decoding first without, so coefficient of 1 I'm decoding first, or a triplet I start with coefficient of 1, then coefficient omega and coefficient omega square. So your coefficient of 1 is 2c rather, plus coefficient of omega is a and omega square is b. So that decodes in my new world as 2c comma a comma b. And that's something surprising because that's the second column of this matrix. Okay, hold your breath. And now let's define alpha omega square. Okay, so we have defined alpha, we have defined alpha omega, and now what's alpha omega square? Let's multiply with this omega square. So a omega square plus b omega cube plus c omega 4. Hold your breath now. It's b plus a omega square plus c omega cube times omega. And since omega cube by definition, notation we have 2, so it's b plus 2c omega plus a omega square. And that gives a new coding of this expression alpha omega square is b 2c comma a, and which is surprisingly third column. So let's see whether it's omega cube is 2, so b omega cube is basically 2b, right? So that gives a coding 2b 2c comma a. 2b 2c comma is exactly the third column of our matrix. And isn't that magical? Isn't that magical? So what I am telling is, now I can decode this entire matrix. So now I can decode this abc. We have 2cab and 2b 2ca. So this entire determinant actually can be decoded with just a number called abc, with alpha defined to be a plus b omega plus c omega square. So basically what we are doing is we are decoding it, it's alpha omega, and the third column is alpha omega square, right? So every time now I'm multiplying two numbers of this fashion, basically you are multiplying two matrices or two determinant in that case. So let's see if I have some number. Okay, let's start with our actual answer. For example, we started with the solutions. Our seed solution was 111. So alpha decodes to 1 plus omega square. Now if I have a number alpha 1 plus omega square, what if I multiply this with itself? It will clearly give a number exactly in this fashion. Why? Because the product of any two values of alpha of the same family is definitely going to be in this fashion. कैसे? क्योंकि अगर मान लो अब तुम कुछ भी ले लो a plus b omega plus c omega square, you multiply this with a dash plus b dash omega plus c dash omega square, definitely you'll get a dash plus we'll have terms like b dash omega square plus bc dash omega cube and so on and so forth. So finally we'll have something plus something omega and plus something omega square. The point is very clear. So this guys will still, we can decode this and create a matrix with this golu and golu ka bhai bv, golu bv, and again we can multiply this with omega, so that will create the second column, omega square will create the third column. So by the way, what I have shown, there is a bijection between this and this. Okay, and if indeed if we multiply 1 plus omega square and 1 plus omega square, that will give 1 plus omega square plus omega square plus omega cube plus omega square plus omega cube plus omega 4. And let's collect all terms and see what magic is happening over here. So we have 1 plus omega square plus omega square, omega cube is 2, omega square, omega cube is 2, and omega 4 is 2 omega, because omega cube is 2. So how many such omega you got? We have 1, 2, and 3. So 4. 1 plus 4 omega. And how many omega square? 1, 2, 3. Omega square, how many 2's? 2, 4, 5. So finally what we got is 4 plus 5 plus 4 omega plus 3 omega square. And aren't you surprised? Aren't you surprised? Because our next candidate solution here was 5, 4, 3, and which we have retrieved just by multiplying to abstract algebraic structure. That's exactly the coefficients of 1 omega and omega square over here. So 5, 4, 3 decodes to a matrix 5, 4, 3, and then you have that 10, 4, and 3, and then 10, 8, and 3. I guess this was the structure 2CAB, and then okay, it was 2CAB, so 6, 4 in this thing. So anyway, now you can fill it. So I hope you have enjoyed this. So by this, what I have shown is finally I created a morphism, and what I told is if I take any power of this, any power, and it can always be written as a plus b omega plus c omega square. And that shows there is one-to-one bijection between uh, 1/3 root of 2 and this. Now the question is why I have selected that particular number omega as 2 power 1 by 3. That's very obvious because you wanted 2 in picture. Okay, so I wanted ABC and I wanted to get 2 by multiplying something, and again it should repeat in a cycle. So if it were 3, probably will start with 3 power 1 by third. Since it's 3 columns, so 1/3. If it will be 4th column, you want cyclicity of 4. If it is 5th, you will take power 1 by 5th, and so on. So that hint of what to do was very obvious. And this is something which is known as closure property or the case logics. In algebra, if you multiply two numbers of that form, a plus b omega plus c squared, the result is always another number of the same form. And because the matrix and the number are isomorphic, so basically it's mirror image, so multiplying these two matrices from set S will always result in a matrix that stays within the set S. This means you can never fall out of the set by using those n powers. Okay, and that's literally something which is astonishing and crazy. In fact, if we'll multiply 3 times, we'll exactly retrieve okay, we'll get the information that we have done before. And this has some fanciful name, well, like sometimes what I call is copy paste rule or closure. So whole number plus whole number is whole number into whole number is whole number. So our set was just like that. When you multiply two matrices, you are doing a lot of multiplication, adding two of numbers. And because of the shifting patterns, the results are exactly where they are supposed to be. So it's like a track for a train. Once the matrix is on the track, the set, it can go forward as much as it wants. So powers mm square, but it can never jump off the track into a different set. So that was something, I guess, like a very beautiful aspects of mathematical structure, where seemingly completely different mathematical structure can save you and can connect with the unknowingly different structure. And that always surprised me, and also surprised you as well. Thank you. Have a good day. If you are really enjoying these lectures and you feel the quality content is provided you for free, so please do like and subscribe and comment as much as you can so that I can bring more such quality content for free. Thank you. Have a good day. Stay happy, stay healthy, keep enjoying mathematics.